depends. So everything from here for the rest of the day is optional. If you want to take a mathematical deep dive with me, it's going to refer back to some stuff we learned in Math 105. It's going to connect to that thing you learned yesterday called Pascal's triangle, and satisfy your curiosity if you're wondering if there's a more mathematically direct way of getting those coefficients. Okay, so let's actually refer back to Pascal's triangle. So when you studied this in the last homework, you realize that it's a really somewhat bomb-proof way of getting the coefficients you need. For example, in Mike Smith's chicken flock, when he bought 7 birds, all you have to do is go down to row 7 and then grab those coefficients off of row 7. You know, they're right there. But the problem with Pascal's is that in order to have row 7, you have to have row 6. And in order to have row 6, you have to have row 5 and 4 and 3 and 2 and 1. And actually, technically 0 up there. And that's a problem when you have samples that you've drawn of size 100, 1,000, 10,000, because you don't want to be going 10,000 rows down this thing. So it helps to have a more direct way of figuring out the coefficients. So what I want to kind of do is walk through the math of how you do that. And this is why it's a deeper dive, because there is a little bit of what's called the fundamental counting principle that we learned about in Math 105 involved. We've also learned it a little bit here. When we've multiplied probabilities, we've inadvertently used the fundamental counting principle. What it says, pretty simply, is if you can do one thing a certain number of ways and another thing a certain number of ways, then doing both of them, you just multiply them together. We've been using that principle all term. I mean, think about this. You roll a single die, it can fall 6 different ways. You roll a pair of dice, it can fall 36 different ways, because 6 times 6 is 36. You roll 3 dice, it can fall 216 ways, because 6 times 6 times 6 is 216. So we've been using it kind of off the cuff all term. But how it applies to this, that's what I want to go through today. So what I'm going to do is we're going to look at his case of 7 birds that he bought. So behind me now you see there's 7 birds. Now, how many ways, let's go through the coefficients. Let's go through the distribution actually. If you buy 7 birds, you're either going to have no girls, 1 girl, 2 girls, 3 girls, 4 girls, 5 girls, 6 girls, or 7 girls. There's 8 possibilities. You may have noticed that in Pascal's triangle, when you're in the 7th row, there are actually 8 possibilities, and that's because 0 is a possibility, 0 up to 7 in this case. So when you have, if you want no girls, well, pretty clearly, there's only one way to get that, and that's not choose any of them. So in other words, all the chicks you see above me are all male if there's no girls. Now mathematically, the way this is written, it's written in words and in symbols. The way it's written in words is 7 choose 0. So you have 7 things, and you're going to choose none of them. Mathematically, it also has a symbol that is sometimes used. I'm not sure how much it's used anymore, but you put 7 kind of floating over 0 and put parentheses around it. That's what I grew up learning. I'm not sure if it's still in favor or not. But both of these things equal 1. And what's so cool is you can type either of these things directly into Google. I'm going to go with the verbal one here, because the verbal one actually is much, much easier to type into Google. And there you go. Google tells you it's equal to 1. As a matter of fact, any number choose 0 is equal to 1. Because it doesn't matter if you have 7 chicks, 70 chicks, 1 chick, 1,000,000 chicks. If you're not going to choose any of them, then there's only one way to do it. Don't choose them. Hopefully that makes sense kind of theoretically. What I like to do now is actually jump to the other end. What would happen if we chose all 7 of the chicks? So in other words, 7 choose 7. Which would look like this, mathematically. Well, if you're going to choose them all, I would argue you still only have one choice. You've got to choose them all. That's the only thing you can do. You've got to choose them all. So both of these things are equal to 1. And you can verify with any calculator, like Google, that 7 choose 7. anything, choose all of it, is going to be equal to 1. Those correspond in Pascal's triangle to the numbers on the end. Now, I know we haven't gotten into any mathematics yet. That's coming next. And let's look next at what happens if we only choose one of the 7. All right. Now, we still got the birdies up there. But now, we want one of them to be a girl, and therefore that leaves the other 6 to be boys. Hopefully that makes sense, because the other 6 it's binomial, either a girl or a boy. Okay. We're going to choose the one to be a girl. Okay, it could be the first one. Could be the second one, could be the third one, could be the fourth one, could be the fifth one, could be the sixth one, or could be the 7th one. 7 ways to do it. And you probably noticed this as much in every distribution we did. Not at the end caps, but the first coefficient in, down from the top and up from the bottom, always matched how many items you had in your trial. And that makes perfect sense, I think. So, mathematically, 7 choose 1 is just 7. It's just 7. How about written the other way? 7 choose 1, 7. And verifying with Google. Now here's what's cool. Here's what's cool. What if we wanted to choose 6 of them? So if you want to choose 6, well, we can actually work through all the possibilities. But I mentioned something previously. In a previous homework or video, I don't remember exactly what it was. It's easier in this case, rather than counting the 6 that you want to be girls, count the 1 that you want to be the boy. Because that's going to give you the exact same result. So the first one could be the boy, the second one, the third one, the fourth one, the fifth one, the sixth one, and the 7th one. So 7 choose 6 is 7, as you can verify. So, and you notice that in Pascal's triangle, those 2 7s that popped up there on the end caps. So far we haven't really had to do much math, we're just kind of thinking through it. I think it gets more interesting when we think about, let's choose more than 1, but less than 6. Let's do it. Okay, what happens if we choose 2 birds? From 7. Okay, so we're still looking at our 7 chicks up there. Now, one way to do this is kind of the way we've done in the past. We have to just pick the 2 that we want to be girls and just exhaust all the possibilities. Okay, so let's do this old school, for starters. So we're going to start, I'm going to keep it simple. I'm going to make birds 1 and 2 be the girls. Okay, so that's one way right there, birds 1 and 2. Another way is 1 and 3, 1 and 4, 1 and 5, 1 and 6, or 1 and 7. Okay, so that's 6 ways right there. But in all 6 of those ways, I forced the first bird to be a girl. She doesn't have to be a girl. She might be a boy. So let's look at some other ways. Let's reset, but let's put bird number 2 and bird number 3. So that's 6, 7. But it could be 2 and 4, 2 and 5, 2 and 6, or 2 and 7. I'm out of fingers and I have to use toes. I better start writing some of these down so I don't lose track. So far I've got 11. I've got 6 ways plus 5 ways. Ooh. Now if I bump them down again and I start with birds 3 and 4, I can go 3, 4, 3, 5, 3, 6, 3, 7. That's 4 more. That brings me to 15. And then if I start with 4, 5, 4, 5, 4, 6, 4, 7, that brings me 3 more. Now I'm at 18. And then if I bump it down to 5 and 6, it's either 5, 6, 5, 7. That's 2 more. That's 20. Keep that in my head now. And then it could be 6 and 7. So there's 21. 21. Now, anybody watching this video still is disliking me a whole lot because, number one, you're going to say, Sean, I'm going to type it into Google and figure out that it's 21. But also, there's some of the rest of you are going to be like, Sean, what the hell? This is absolutely ludicrous. There's got to be a better way to do this. Before we do, I just want you to realize something. That 7 choose 5 is going to be the exact same thing for the aforementioned reasons we just discussed, which is it doesn't matter which way you count, whether you're counting the 2 birds that need to be girls or the 5 ones that need to be boys, that's counting the same thing in 2 different ways. Okay. But for those of you at this point who have gotten tired of watching me do this and who really don't want me to figure out how many ways we can count 3 of those chicks to be girls, let's take a deeper dive into the math now.